Okay, hey, welcome back. This is College Algebra 10.2. We're looking at a particular kind of sequence here, and it's called the arithmetic sequence. Okay, this is the most kind of generic sequence there is. Let's look at an example of one. So we have 2, 5, 8, 11. Can you guess the next number? It's 14, right? So how did you get 14? Well, you added 3, right? So you sort of added 3. Every one of these, all we did to get to the next one was to add 3. Okay? And that's the defining characteristic of these sequences. To get to the next term, all you have to do is add this what they call a common difference, okay, which they'll call D. So let's go ahead and introduce this with a definition then. And our formula will be a sub n equals the previous one, so this is a recursive definition. A sub n, the next guy in line, is equal to the previous guy plus this common difference value. So let's make that official. Common difference. And there's that. So let's look at some of the intro problems in the book. So problem 1, we have a sub 1 equals 200. And our common difference is 20. And we want to produce the first 4 terms. So the first guy is 200. The second one, you just add 20, so 220. The third one is then 240, and then the fourth one is 260. And you could, of course, carry on if you wanted to. Let's not. Number 6, so A1 is 200, and then our common difference is negative 60. So you can have negative numbers for your common difference. You can have a sequence that's going downwards, so to speak. A decreasing sequence is probably a better word for it. So 200, and then 200 minus 60 is 140, and then minus 60 again is 80, minus 60 again 20, and then so on, right? Let's look at one last one. I think we got it, but let's look at one last one. So this is a sub n equals a sub n minus 1 minus 20, with the a sub 1 given as 50. So this time it's written in our recursive definition form, and we don't necessarily have the D value, but the D value is right here. Okay, so anyways, a sub 1 is 50, and then a sub 2 is just a sub 1 minus 20. So again, like the D number is minus 20. Okay, so a sub 2 is 30. A sub 3 is going to be 10. And then a sub 4 goes negative 10. Okay, and then it would go on and on. Okay, we want a general formula, that nth term formula. So if you ask me what is a 3000, I can tell you. I don't have to go through a sub 1, a sub 2, all the way up to a sub 2999, right? So that's what I'm after. And this is where we're going to try to get it. So the general term formula for the arithmetic sequence. And first we're going to do some what they call iteration. Just look at what's going on, okay? And then maybe we can see a pattern, right? So a sub 1 is always just a sub 1. To get to a sub 2, we take a sub 1 and add in that common difference. Okay? A sub 3 is basically a sub 2, which is a sub 1 plus D, and then we have to add in another common difference. Right? And we could simplify this. This is a sub 1 plus 2D. A sub 4 is going to be a sub 3, a sub 1 plus 2D, plus another D. So a sub 4 is going to be a sub 1 plus 3D. You can kind of see in a pattern here. So a sub 5 is a sub 1 plus 4D. Right? So it's just a sub 1 plus 1D, a sub 1 plus 2D, a sub 1 plus 3D, a sub 1 plus 4D. A sub 6 will be a sub 1 plus 5D. And you can keep on going. Let's say a sub 20. Right? What do you think a sub 20 is? Well, it's a sub 1 plus not 20D, 19D. It's always one less than the subscript, right? So in general, if we wanted our nth term formula or our general formula, it should be a sub n equals a sub 1 plus 1 less than n times d. And that is the thing we're after. This guy right here is our nth term formula, or as we said above, the general term formula. So we won't have to go through this recursive process every time we want to figure out a particular value in the sequence, right? Okay, so let's take a look. 16, number 16, find a sub 16 when a sub 1 equals 9 and the common difference is 2. Okay? So we could just use this formula. A sub 16 will be a sub 1, which is 9, plus n minus 1. So the n value is 16 here. So 16 minus 1, and then times 2. Right? So this little subscript 16 is the n value. Okay, so we can simplify that. 9 plus 15 times 2 is 39. Okay, so we don't have to go through that recursive process. Number 24, they want you to find the formula, find the nth term formula for the sequence for the general term. And they basically give you the sequence. So 2, 7, 12, 17, etc. So what do we need for our formula? A sub n is equal to a sub 1 plus n minus 1 times d. I need a sub 1, so a sub 1 is 2, and I need the d value. And all I have to do to get the d value is just take the difference of two terms. So 7 minus 5. You always go like a sub 2 minus a sub 1, not a sub 1 minus a sub 2. Okay. So this will be 2. So maybe I should define that somewhere. This common d value, this difference, will be something like a sub n minus a sub n minus 1. Okay. Anyways, let's plug this material in. So our nth term formula will be 2 plus n minus 1 times 2. And let's make it look pretty. So that'll be 2 plus, if I distribute, 2n minus 2, which will just be 2n. Which completely and utterly does not seem right. 7 minus 2 is... Oh, it's 7 minus... I wrote the answer. I got ahead of myself. Sorry. So 7 minus 2 is 5, so this will be 5. I was just looking at it. The formula didn't work. So here, let me fix that. Sorry about that. Okay, so this is then 2 plus 5n minus 5. So this will be 5n minus 3 at the end of the day. And you want to check, make sure it works. So when it's 3, you'll have 15 minus 3, which is 12. And yeah, that's the third term. Okay, let's get one more of those, considering I butchered it. So 26, we have 6, 1, negative 4, negative 9, blah, blah, blah. Okay, so again, we're going to need a sub 1, that's 6. I'm going to need the common difference, so that will be 1 minus 6. This time the common difference is negative. Then plop it into your formula, so a sub n equals a sub 1, which is 6, plus n minus 1 times d, which is negative 5. And then make it look pretty. 6 minus 5n plus 5 is 11 minus 5n. Make sure it works. So the fourth term should be negative 9, right? So 11 minus 5 times 4 is 11 minus 20, which is, yeah, it works. Okay, one thing we're going to want to do is add these things up, okay? And we start with the arithmetic sequence, but now we are going to be adding up the terms of the arithmetic sequence. So we'll have things that look like this. And we want formulas to figure those out, so we don't have to sit there and add them all up. Okay? And there are, because of the fact that this kind of has, these things have structure to them, we can figure out formulas for the sums. Okay? And that's what we're after right now. So this section, I think it's 3 in my notes. If not, just edit that appropriately. It's the sum of the first n terms of an arithmetic sequence. Okay, so first things first, I need to get a formula for this guy. And, well, anyways, just in general, we could look at what are called partial sums, okay? And call the sum of the first term. Okay, what is that? That's a sub 1. The sum of the second term, what is that? That's a sub 1 plus a sub 2. The sum of the first 3 terms, that's a sub 1. Is this kind of obvious? It's a sub 2 plus a sub 3. The sum of the first n terms is going to be a sub 1 plus a sub 2 plus a sub 3 plus dot 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 plus a sub n. And we can use summation notation for this. Some other reasons why we introduced summation notation was for this purpose. I equals 1 to n of a sub I. Right? Okay. Finding a formula for this. So I just want to give you an example that I think will sort of make you gravitate towards the formula. So note the sum of 1 through 100. So the first 100 terms of this arithmetic sequence with a common difference of 1, right? So S sub 100. What is that? That's 1 plus 2 plus 3 plus 4 plus dot 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 plus 100. And I want to know what that equals. Well, somebody figured out a trick. I think it was Gauss or somebody like that, some famous mathematician. Look, added it to itself. This is pretty weird, okay? But in reverse order. So they went 100 plus 99 plus 98 plus 97 plus dot 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 all the way down to 1. Okay, and what do you get? You get 2 sums of the first 100 terms. On the other side, what do you have? You have 100 plus 1 is 101, plus 99 plus 2 is 101, plus 98 plus 3 is 101, plus 97 plus 4 is 101, all the way down to 101. Well, that's kind of cool, right? How many are there? How many of these are there? Well, if you use the above sum to count them off, there are 1, 2, 3, 4, all the way up to, well, there's 100 of them, right? There's 100. So one way of writing 100 101s is 100 times 101. So this equals 100 times 101. Okay. All right. Then I just divide both sides by 2, and I get 100 times 101 all over 2. And so what is this thing? Well, it's the number of terms you have, right? 100 times the first term plus the last term, or really you could use any 2 terms as long as they're spaced correctly, and then divided by 2. Okay? So what I'm getting at is the formula for the sum of the first n terms of an arithmetic sequence. Okay, that's this formula. And I haven't really proved it or anything, but hopefully it gives you a kind of a, okay, you're willing to believe it. Okay, I hope that's what you gained from this. Okay, I think that's reasonable, and let's just leave it at that, right? Okay, so that's our formula, and the formula for the first n terms of an arithmetic sequence. Excuse me, is that? Okay, so let's actually do some problems. Here's 36. find the sum of the first 25 terms. Right, so here's our sequence: 7, 19, 31, 43, blah, blah, blah. For my formula to work, I need n. Okay, n in this case is 25. I need a sub 1. A sub 1 is clearly 7. And then I need a sub 25, right? Because I'm looking for s sub 25 here to the right. That's equal to 25 times a sub 1 plus a sub 25 all over 2. So I need a sub 25. I don't have a sub 25, and I'm not going to sit there and squirrel through all of them to get it. I'm not going to do the recursive definition. So I need to go to my general formula. Okay, so I'll do that. A sub n is equal to a sub 1 plus n minus 1 times the common difference, which is apparently 12. So this is 7 plus 12n minus 12. So a sub n should be 12n minus 5. Okay, and then that will allow me to figure out a sub 25. Right, so a sub 25 is going to be 12 times 25 minus 5. Let's see what that was. 12 times 25. My calculator broke. 6, 4, 2, 0, 0, okay, 1, 300, minus 5 is 295. Okay, great. So a sub 25 is 295. Now I can figure out the sum of the first 25 terms. Okay, so that's going to be 25 times 7 plus 295 all over 2. And then defaulting to my calculator now, that will be 3775. Okay. Let's do 1 or 2 more and then look at an application. So here's 44. Find the sum of the odd integers between 30 and 54. Okay, so this sequence, what is it? Well, the odd integers, okay, so 31, 33, all the way up to 53. Okay, I don't know how many there are, so that's one thing. I have to figure out n. That's pretty much the only thing I need to figure out, right? Because a sub 1 is 31, and then this last term, yeah, I don't know what that n value would be. It's 53. Okay, so I got to figure out how many terms are there. How do I do that? You could use the nth term formula again, the general formula. You could say, okay, so a sub n is equal to a sub 1, which is 31, plus n minus 1 times the difference, which apparently is 2. Okay, so that'll be 31 plus 2n minus 2. So a sub n will be 2n plus 29. And then to figure out the n value of this last term, you just plug it in for a sub n. So 53 equals 2n plus 29. 2n equals 53 minus 29, 4, 13, 4, 2, 4. And then divided by 2, and you get n is 12. Okay, so our n value is 12, and a sub 12 is 53. Okay, so then my sum of those first 12 terms in that arithmetic sequence will be 12 times 31 plus 53 all over 2. Okay. And you put that in your calculator, you get 504. Let's look at one more. This time they're going to actually use the summation notation. That's nice. You know, we learned it for some reason. I equals 1 to 20 of 6i minus 4. Okay, we could write it out if you wish. 6 minus 4. When I is 1, you'll have 6 minus 4, which is 2. When I is 2, you'll have 12 minus 4, which is 8. When I is 3, you'll have 18 minus 4, which is 14. And then on and on up to 20. 6 times 20 is 120. Minus 4 is 116. Okay. So I need, as usual, my n value. And in this case, how many are there? Well, there's 20 of them. I goes from 1 to 20. A sub 1 is 2. And then a sub 20 is 116. So that's pretty easy. S sub 20 is then 20 times 2 plus 116 all over 2, which should be 1180. Okay. Okay, finally an application. So you're offered jobs at 2 companies. This is on page 1061 if you want to look it up real quick so you have a better idea what I'm talking about. But I'll try to walk you through it. So you have 2 job offers, one from company A, and their starting salary is $19,000. But they're going to give you a raise of $2,600 per year. Then there's a rival company, B, who's offering you a starting salary of $27,000. That sounds better, right? And then raises that aren't as good as the other place, only $1,200 per year. And you got to figure out where you should work, because all you care about is money, right? All right, so which is better over a 10-year period? Okay, so essentially what they want you to do is add up an arithmetic sequence starting with a sub 1 is for company A. So let's do company A first. A sub 1 is 19,000. And then a sub 2 is 19,000 plus 2,600, whatever that is. And then a sub 3 is 19,000 plus 2,600 plus 2 times 2,600, etc. Add that up. So S sub 10 is what we're after, and that'll be n, which is 10, times n sub 1, which is 19,000, plus n a sub 10. Okay, so a sub 10 should be, well, if you're not sure, you can always construct the general term formula. So a sub n will equal 19,000 plus n minus 1 times 2,600, the raise. And then if you simplify this, it would be 19,000 plus 2,600 n minus 2,600. 19,000 minus 2,600. I have to figure that out. Ugh. Let me get my calculator. Computer calculator. So what do we got? 19,000 minus 2,600. Ticking me off. 19,000 minus 2,600. 16,400. And so a sub 10 will equal 26,000 plus 16,400, which is 42,400. Right, so it'll be 19,000 plus 42,400 all over 2. And if you put that into your calculator, I believe you get $307,000 over 10 years. Okay, let's look at the other one, company B. So their starting salary, A sub 1, is 27,000. And their common difference is 1,200. So again, our sequence is going 27,000 and then 27,000 plus 1,200. And then 27,000 plus 2 1,200s, etc. We need S sub 10 again. S sub 10 will equal 10 times A sub 1 plus A sub 10 all over 2 if you need to figure out A sub 10. Again, find the nth term formula. So A sub n equals 27,000 plus n minus 1 times 1,200. So that equals 27,000 plus 1,200 n minus 1,200, which means A sub n equals 1,200 n plus 27,000 minus 1,200. It's 25,800. So A sub 10 then is going to be 12,000 plus that. So 12, 1, 2, 3, plus 2, 5, 8, 0, 0, 37,800. So that goes here. And if you pop it into your calculator, you get $324,000 over 10 years. So at least financially speaking, if you're only planning to stay there for 10 years, the company B is the better deal. B will pay more over a 10-year period. Okay, so we'll leave it at that, and as usual, thank you for watching, and we will see you next time.